The next algorithm is KNN, which is called as K nearest neighbor algorithm. In this, we'll see what is KNN. KNN is a supervised learning algorithm which is used for classification and also for regression process. The next is it classifies all the new data points based on the majority classes among K nearest neighbors. Next is it is a lazy learner, no training phase is required. It uses the distance metrics to compare the data points. So among this definition, we come to know that it falls under the category of supervised learning. It not only used for classification and regression, and what is a major role played by the KNN is it find out the nearest neighbor point to the to make the prediction. So even though the process which is carried out is a very slow process and is also does not require any training phases. The it, all the predictions are made on the distance metrics compared with the nearest data point. This is the logic behind KNN. Now we'll see how the KNN works. First, it chooses how many number of neighbors are available with the central point. And then it calculates the distance that we call that distance is a Euclidean distance. So we'll take the reference point. We call that reference point as a test point. From that test point, we find out the nearest neighbor point. So from the test point to all training points surrounded by the test point. Then the next step is it picks the k nearest training points, which is very close to the test data. Then after that, it goes for label the data sets. So which label has majority points it is covers. That data set it takes, that particular point it takes and it validates it. So this is how the KNN start working. So next is going to be, we are going to take one example under this process or to explain the concept of KNN. So here the example is, we have a data set which consists of different types of fruits. We are going to predict what type of fruit it is. So for defining the fruit, I'm going to take three classifications. One is a weight, another one is size, and third one is a fruit. So first weight in terms of grams I'm going to define. What will be the size in centimeter and what type of fruit it is. So weight, so totally I've taken a six different categories of weights. One is 180, 200, 170, 300, 320 and 340. Sizes have been classified as 7, 8, 6, 10, 11, 12. Now I'm going to assign a name for the fruit. So if it is 180 size is 7 centimeter, it is apple. 200 8 centimeter means it is defined as apple. 170 gram size is going to be 6, then it is also classified under the category of apple. If it is more than 170, that is 300, 320, 340, and the size is more than 6, the maximum size of apple is 8. Here, maximum 8, whatever the size we have it, I classify that into the group of orange. So, among this data set, I'm going to make a test point. That test point is in between all the six different weight and sizes. I'm going to fix a test point that is called 290 gram, and its size is going to be 90. This is a centric point. This is what we call it as test point. Now, after defining all these things, I'm going to calculate the distance. That distance we call it as Euclidean distance. The formula for Euclidean distance calculation is square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. This is a formula for Euclidean distance calculation. Now, we are going to reframe the the table what we have it. I'm going to call it as one is a training point, another one is a fruit, and how much distance I'm going to calculate from these two data, two classifications. Training point are nothing but I'm combining the size of the weight. 180, 7, 200, 8, 170, 6, 300, 10, 320, 11, and 340, 12. And I know that what is a fruit classification is apple, orange. Now I'm going to calculate the distance with the test point of 290, 9. So applying this formula of x2 minus x1 the whole square plus y2 minus y1 the whole square within square. So I'm getting a value of what? Around, for the first data, I'm getting a distance of about 110.02. For the second data, I'm getting a value of 90.01. On the third data, I'm getting 120.04. So fourth data, I'm getting 14.14. And fifth is going to be 36.06. And sixth is going to be 33.15. This is the distance I'm calculating with respect to the test point. After calculation, I'm going to predict. I'm going to keep my k value to be equal to 3. Some value I'm fixing for k. So the nearest neighbor, so when we go to the table, we can see in the previous table, we have so many datas we had it. In that data set, we had a table called the nearest neighbor. Nearest neighbor means the distance is very less. If the distance is very less, I'm going to collect those values and I'm going to say that these are the point which is very close to the test data. So among that, from the table, I found that 300, 10, 320, 11 and 340, 12 having a very less distance. So this distance are very close to the distance, test point. So now when I gone for the classification, I found that these above neighbors, the corresponding fruit which I can classify is going to be orange. All the three categories are represent the orange fruit. So now the majority, when you find it out from this value, the majority votes only for orange fruit. So now I'm giving the majority class is equal to orange. The predictor for 290, 9 test point value, the fruit which I'm going to predict is going to be orange. So this only has been mapped in the or plotted in this graph. So fruit was size versus size versus weight. So among that, I found that orange, orange in one color, apple in one color, and the test point is shown in the black color. So we are going to, this is how I plot the graph. Next, so this is how without training the data set, I'm finding out the Euclidean distance. From that Euclidean distance, I find out which is with the respect to the centric point, what the data which is closer to that centric point. This is one of the way we can find it out, or we can predict the outcome. So what are the advantages and disadvantages of using this KNN algorithm? When you comes under the disadvantages, you can see that it's very simple to understand and easy to implement. Since there is no training phases is required, all the processes are very easy. This will be effective only for small data sets. I can't go for applying the KNN algorithm for the large data sets. Disadvantages is with this very slow when I go for applying this KNN algorithm for the larger data set. This causes it is easily affected by noise, irrelevant features, sensitive to the feature scaling. These are the disadvantage of KNN algorithm. So what are the applications I can follow? Where I can apply this KNN algorithm is handwritten recognition, medical diagnosis, and recommender system, image classification, bank credit scoring. For all this process, I can apply this KNN algorithm. I